Hello, everyone. I'm your physics teacher. My name is Mr. Alexander. Today's topic is on linear momentum. Let's see what we are going to learn about linear momentum. First and foremost, let's consider some of the things you need to know, the previous topic. What is a force? Paul, can you tell me what's a force? Okay, push and pull. Oh, that's right. What's the unit of force? James, can you tell me what's the unit of force? You say Newton? Correct. What is resultant force? Is anyone there who can tell me what is resultant force? Oh, Kelvin. Oh, I get what you say. A single force obtained from the combination of two or more force added vectorally. Oh, that's great. Let's move ahead. What is acceleration? Acceleration, anybody can help me? Lucy, can you tell me acceleration? Oh, that's great. The rate of change of velocity with time. You're correct. Then can you also help me? What's the unit of acceleration? Meters per second per second. You have all done well. Now, for linear momentum, let's consider a learning objective. We have to state and explain momentum, to state and explain impulse of a force. Then we move into solving problems involving momentum and impulse. Let's start. Momentum of a body is defined as the product of its mass, m, its velocity, v. Mathematically, you have that written there. P is equals to mv. What that means is that momentum, since velocity is a vector quantity, momentum is also a vector quantity. And momentum is measured in the units of kilogram, meters per second. Meters per second. Momentum, depending on the formula, the equation, P is equals to mass times velocity. Momentum is directly proportional to the velocity vector. This means that from the equation, momentum, mass times velocity, that means momentum is directly proportional to the velocity, and momentum also, depending on the mass, if you increase the mass, the momentum is also increased based on this equation here. That means any of this quantity the parameter decide to increase. You want to increase the velocity, the body is moving faster with the speed, the velocity, momentum also increase. So momentum goes along with the product of the mass and the velocity. So changing the momentum, one must change the mass or velocity or both. Okay, here's an example. Let me solve this example. What's the momentum of a body of mass 2 kilograms moving with a velocity of 10 meters per second? In this question, here we have the mass given to us as 2 kilograms. And the velocity is 10 meters per second. That's 10 meters per second. The momentum, which is mass times velocity, will become 2 times 10. I'll give you 20 kilogram meters per second. Remember, the unit of momentum is kilogram meters per second. Let's discuss impulse. Impulse of a force is defined as the product of the average force acting on the particle at the time during which it acts. Paul, remember when we say force, is a push or pull on an object. So the product of force and time at which the force acting on the body will give you the quantity known as the impulse of the force. Please note that the unit of impulse of the force is Newton second. Newton second. If we have impulse, which is force times time, And probably from this equation, we can also say that the force is impulse all over time. Likewise, we say the time is the impulse divided by the force. But note that the unit of impulse, that is Newton second. Newton second. Here's an example that has to do with impulse. A stationary ball is hit by an average force of 50 Newton for a time of 0.03 seconds. What is the impulse? This question, the parameter given to us, the force here is 50 Newton. The time duration at which the force acted on the body is 0.03 seconds. And remember that impulse of a force is force times time. 50 times 0.03. That will give us the impulse of a force as 1.5 Newton second. That is the impulse of a force. Okay, let's consider Newton's second law. Newton's second law states that the rate of change of momentum is proportional to the applied force and take place in the direction of the force. Kevin, do you understand that? The rate, from that rate of change of momentum, proportional to the applied force and take place in the direction of the force. Yeah, the derivation of this law, Newton's second law, the derivation of Newton's second law enables us to get a fundamental equation which states that force is equals to mass times acceleration. That is, this is Newton's second law, the mathematical statement of Newton's second law. The rate of change of momentum, the rate of change of momentum is proportional to the applied force. We need to understand from this derivation, impulse of a force is equal to change in momentum. Yes, we can write I, change in momentum. Change in momentum. That means that we can also put it in this form. Impulse of a force. Let's solve some problem. The first question, question number 1. Kelvin, can you help me with it? An unbalanced force of 20 Newton acts on a 4 kilogram mass. What acceleration does it gives? What acceleration does it gives? Okay, any one of you, class, can you solve it? What's the value? Okay, let's work this together. In this question, the force is given to us, which is 20 Newton, and the mass is 4 kilograms. We're asked to find the acceleration. And remember Newton's second law, say that force is ma. We are looking for the acceleration, which is force all over mass. When you substitute the value, 20 divided by 4, 20 divided by 4, that will give us the acceleration of 5 meters per second per second. Is that what you guys, or Kelvin, you say you have that value? Yeah, that's right. It's good. We have another question here. I want everybody to solve it. I'm giving you 2 minutes to solve that question. A 9 kilogram stone is pushed along a tarmac by horizontal force of 20 Newton, the frictional force of 8 Newton. 8 Newton opposes the motion. What is the acceleration given to the stone? What is the acceleration? Okay, can I have you guys solving the question? Can I have you guys solving the question? Okay, okay. Remember, list out the parameter given to you. List out the parameter given to you. Okay, let's do it together. We have the mass, which is 900 kilogram. We have the force giving us 20 Newton. We have the frictional force, which is 8 Newton. We are asked to find the acceleration. In this situation, the resultant force here will be 20 minus 8. 20 minus 8 will give us 12 Newton. And following Newton's second law, that says MA, the acceleration would be resultant force divided by the mass. That is 12 divided by 900. That will give us 12 divided by 900 will give us 0.01 meters per second. That's the acceleration. I hope you guys understand the question. Okay, thank you all. We have this assignment. Do it when we meet next class. We'll do it. So I'll give you some minute for you to copy the assignment. The next class, I expect you to submit the assignment. Okay? I'm sure everybody has copied the assignment.